Hello and welcome to Lesson 9, the inverse function. And this is Advanced Pre-Calc. This is Mr. Tomlinson. So we're going to start with inverse functions and the definition. It's clear to see that in this case, the definition of inverse functions are where you have two functions, f and g, and f of g of x is equal to x, and g of f of x is equal to x. Then this is true if and only if. That's what, whenever you see IFF, that's what that means, if and only if this is true and that is true. So basically, remember if and only if from geometry, that basically means a biconditional statement. That means P implies Q and Q implies P. So it works both ways. Okay, so that's a biconditional statement. So if you find that f of g of x equals x and g of f of x equals x, then those two functions are inverses of each other. Okay, so some quick notational things. If we want to talk about the inverse of a function, we will be writing f to the negative 1 of x. So we call that f inverse of x. So that's the inverse of f. Now, that is not the reciprocal function. It's not an exponent, it's a label that tells us that is an inverse function. So if I want to write this, for example, if I wanted to write the reciprocal function, I would write it differently. I would write it as f of x raised to the negative 1, which would flip everything over as its reciprocal. So that is different than this label here, which is f negative 1 of x, or the inverse of f of x. Okay, so this example says f of x equals x minus 1 over 2, and I want to find the inverse of f. Now, to find inverse functions, and by definition, to do an inverse function, all that's happening is we are taking y equals x minus 1 over 2, and we are switching the x and y coordinates. So every x is now a y, and every y is now an x. So what we've done is just switch the x's and y's. So to change it to its inverse, we just transform it from x. All points become that were x comma y have now changed to y comma x to make the inverse. Okay, so but we can't leave a function like x equals some function of y. We have to then solve for y when we're done. So this will be 2x plus 1 equals y, and that is equal to f inverse of x. And then the example 2 basically says if f of x equals 3/4 x minus 6 and g of x equals 4/3 x plus 8, determine if these two are inverse functions. So what I'm going to do is I'm just going to basically, if somebody asks you to prove or whether or not two functions are inverses of each other, take f of g of x and g of f of x and see if you get x. Go ahead and pause the video and do that, and then come back. So there it is, f of g of x is equal to x, and g of f of x is equal to x. So yes, f and g are inverses of each other. And now it's time to go on to the next video, if you're feeling comfortable.